So you know, for example, that on the surface of the Earth, if I give, for example, that the object on the surface of the Earth, this is the radius of the Earth, this is the mass of the Earth, this is the mass of the satellite. At the surface of the Earth, how do you calculate the weight of the object? mg, which is Fg mg. So at this location, if we know, if we call this Fg, let's say for instance mg or 1000 Newton. Let's say that we have an object, a satellite, that at that, I mean, if it's just skimming the Earth or is at the surface of the Earth, the weight is 1000 Newton. The question can be, if I move this to an orbit that is here, the same m, but an orbit that is 2 radii from the center of the Earth, you just need to go and to the formula and say, okay, since g is the same, the mass of the satellite is the same, and the mass of the central body is the same, what is the only thing changing? The radius. And because it's inversely proportional to the radius, right? Means that if the radius goes up, the force of gravity have to go down, have to be less. So if it's inversely proportional to the square of the distance, and we go 2 radii from the center of the Earth, so we will be in a new orbit that is 2 radii from here, from the center. How much will be the force? How many times will be less? By proportion. 1/4. Because it's inversely proportional not to the distance, to the square of the distance. 1 minute. So will be 1/4. Any question on that? So just by proportion, if the only thing changing is the radius, you know that the force have to go down by 4 times because this square. So if it's 2 radii, now because I am increasing this to 2 square will be 4. Will be 4 times less the new gravitational force at that location. If I go to 3 radii, 1/9. If I said the object will be 4 radii from the center above the surface of the Earth, 4 radii above the surface of the Earth, how much will be the weight less? 125. Because I said 4 times above the radius of the Earth. So in total will be 5 times. I didn't say the radius or the distance, r. I said the altitude. You need to make a difference between orbital radius. Orbital radius is the radius where is the satellite from the center. This is orbital radius, r. And this, if this is the Earth, this distance from here to here will be called altitude, h. 2 different things. So you have to make sure what is given. In the formula, r stands for orbital radius, radius of the orbit. Good. This is one way. The way that you calculate this, I mean, is here is Fg. Here is Fg prime. Since this is 1000 Newton, which is Fg, let me just use formula rather than numbers. And then we use numbers. So, since this is G m over r squared, which in this case is the radius of the Earth, because we are at the surface of the Earth at this location. And here we have a different location, will be G, m, this didn't change. The only thing changing is this, and now is 2 radii. we square. If we divide or use elimination method, which is dividing one equation to the other, stating the proportion, you can see that this fg prime, which is what I am looking for, over fg is, this cancels out. If you multiply by the reciprocal, we get this radius of the earth square on the top, and this 4 radius of the earth square on the bottom. I multiply by the reciprocal, right? So here we get this cancels out, and we get that fg will be equal to 1/4 of fg. This is basically what I explained in other words. This is the way that I will find. So, as a general rule, if I want to get the proportion between two weights at two different locations, fg prime at a new location over fg, I will say, if it's two locations, I will say fg2 over fg1 on the first location will be r1 squared over r2 squared. This is the proportion. So if the force is 1,000 Newton, how much will be the new force at the new location? 250. If it's 2 radii, 250 Newton. All right, this is the first thing we will find. So again, if I give the numbers, you just insert the numbers here and find them. Most of the time, this will be very tedious, and in this class, for the most part, will be proportion, just to know that if you know the concept. Okay, good. This is the first thing we need to know. The universal gravitational constant and how to find the weight or the relationship between two weights at two different locations. The second topic. The second topic is very related to this and will be the acceleration due to gravity. How can we calculate universally the acceleration due to gravity?